Welcome back. This is Geometry Lesson 5.5. We're going to learn about more inequalities. In the last lesson, we learned that larger angles are opposite longer sides in triangles that have different lengths of sides. Longer sides are also opposite larger angles. We also learned that the exterior angles are greater than the measure of either remote interior angles. Let's go a little further. Can a triangle be constructed with the given side lengths? So we're going to test some of these things out. And one of the best ways to do this is with constructions. It would really help if you would go ahead and make 3 drawings. With each drawing, make a segment that is 9 centimeters long. Always start with the longest side. Then using your compass, go ahead and set the measures that are called out in each one of these examples and go ahead and strike arcs. Let's look at the first one. This is example 1A. You have the longest side, which is 9 centimeters. It says to strike a measure of 6 centimeters. So you can see that on the left side of this triangle, and you can see the arc. And when they strike a measure of 5 centimeters and make an arc, you can attach or draw a line from both of these points, and you will see that they do intersect and create a triangle. So we drew the longest side first, and then we constructed arcs with radii equal to the other 2 sides as called out. And for example A, you can make a triangle. Let's look at example B. We have measures of 9 centimeters, 6 centimeters, and 2 centimeters. So we begin just like example 1A, but and we draw the 9 centimeters and the 6 centimeters. But when we draw the 2 centimeters, we can see that the sides will not meet, so we cannot make a triangle. For the third drawing, we find that once constructing radii of 5 centimeters and 4 centimeters, they actually meet together and form one line. So this will not make a triangle. It will make a line, but it will not make a triangle. What we've learned is if the sum of the 2 shorter side lengths is greater than the third side, a triangle is formed. So 6 plus 5 equaled 11, which is greater than 9. In B, 6 plus 2 was 8, which is less than 9, so no triangle. And for example 1C, 5 plus 4 is 9, which is equal to the 9 centimeters, so we have created a line. The first triangle is a scalene triangle. It has 3 different side lengths. As a notation, for example 1B, you would state that the triangle segments do not meet, or segments don't meet. And for 1C, you would say that it is a line, or you could call it A-B-C if you had points, something like that, using a betweenness statement. This leads us to the triangle inequality theorem, theorem 5.5.1. The sum of the lengths of any 2 sides of a triangle is greater than the length of the longest or the third side. So we can see right here the same drawing we had on the last example, and we have a triangle created because the 6 plus 5 equals 11, which is greater than 9. Example 2. If 2 sides of a triangle have lengths of 4.7 centimeters and 6.8 centimeters, find the range of possible lengths for the third side. So we're actually going to look at a range of lengths that would work to create this triangle. So we know that the 2 shorter sides must add together and be greater than the longer side, which we will name x. So 4 plus 7 plus 6.8 is greater than x. 11.5 is greater than x. We have other conditions though. We have other sides. So we can now add x and 4.7, and that would have to be greater than 6.8 to be true. So x plus 4.7 is greater than 6.8. X would be greater than 2.1. So we now have two values. X would have to be less than 11.5 or greater than 2.1. Now there's a third condition, and this is where we add the longer side to the 6.8. X plus 6.8 is greater than 4.7. However, our answer is a negative answer. And remember that when we're measuring distance, or as an example, in this case, lengths of a triangle, we cannot have a negative number. So one of the values when using this will not be a value that we can use. So we'll go ahead and use the value from number 1 and number 3, and it's x is less than 11.5 and x is greater than 2.1. And as a reminder, we can compound those two statements because it's an and write it with the x in the middle and restate it. So with the triangle inequality, the greater angle and the longer side theorems that we have already learned, we've worked with inequalities in single triangles. The next theorem and its converse work with the relationship between included angles and the third side of two angles containing two pairs of congruent sides. So we'll be moving from using one triangle to comparing two. Our next theorem is the hinge theorem. This is theorem 5.5.2. If two sides of one triangle are congruent to two sides of a second triangle, and the included angle of the first is larger than the included angle of the second, then the third side of the first triangle is longer than the third side of the second triangle. This theorem is also known as the side-angle-side inequality theorem. This is a lot of words, but basically what they're stating is this. We have two triangles here, and for both of these triangles, when we compare them, we find that they have two congruent sides. So AB is congruent to KL, and BC is congruent to LM. However, the third side is not congruent. AC is not congruent to KM. The included angle, this means the angle in between the two congruent sides. However, angle B is larger than the included angle L. How do we know this? Well, they've actually given us this information, but you can also visually see this because this is an obtuse triangle and they're using the obtuse angle. And in this case, they're using the acute angle. So angle B is larger than included angle L. Therefore, side AC will be longer than side KM. Now this goes back to the theorem that we learned where it says the larger angle opposite the longer side. This theorem has a converse. So the converse of the hinge theorem is theorem 5.5.3. If two sides of one triangle are congruent to two sides of a second, then the third side of the first triangle is longer than the third side of the second. Then, consequently, the angle opposite the third side will be larger than the angle opposite the third side of the second triangle. The hinge theorem stated that we were comparing two sides and then an included angle. The converse states three sides and then talks about the angle. This is also called the side-side-side inequality theorem. And it's probably a good idea to get to know that so that you can keep the two theorems straight. In this example, we would say, with similar notation as the last, segment AB is congruent to KL, BC is congruent to LM, and then we would state that AC is larger than KM, so consequently angle B will be larger than angle L. Example 4a. We're asked to compare the given measures, then name the theorem that justifies your answer. So they're talking about the two theorems that we just learned. Is it the hinge theorem or the converse? So in example A, we have the measure of angle KNL. And I'll see if I can draw that, if it'll let me. Okay, so there's K and L, and the measure of MLN. So these are the two angles that they're comparing. KN is congruent to ML, and NL is congruent to NL. This is because of reflexive property, so we can always state this. But KL is less than NM. How do we know this? Well, KL has a measure of 5, and NM has a measure of 7. So, because KL is shorter than NM, the angle opposite KL will be a smaller angle than the angle opposite NM. So the measure of angle KNL will be less than the measure of angle MLN. We used 3 sides to compare, and then we stated our angles. So this is the converse of the hinge theorem. We compared the 2 sides that they gave us, and then we compared the sides with the lengths. Let's look at example 4b. We have UV, and we want to know if UV is greater than or less than VW. Well, what do we know? UX is congruent to YX, and VX is congruent to VX. I'm sorry. There we go. But the measure of angle UXV is greater than the measure of angle WXV. How do we know? Well, it gives us the measures. 53 is greater than 37. So the side opposite the larger angle will be the larger side. So UV will be the larger side. So UV will be greater than VW. Example 5. Apply the hinge theorem and solve. Let's look at what we have here. We have 2 triangles. We have 2 sets of congruent sides. We have 2 separate side measures and 2 different angles. Let's look at these angles. This angle is 100 degrees compared to 70 degrees. So this is the larger angle. So we know that 3x minus 1 will be greater than 5 minus x. So let's state that in an equation and solve it. So 3x minus 1 is greater than 5 minus x. If we add 1 and x to both sides, we have 4x is greater than 6. And if we divide both sides by 4, we have x is greater than 3 seconds. But remember, with these problems, we have two answers. So the next step will be to take the shorter side and set it to greater than 0. Remember, it has to be greater than 0. We're talking about lengths here. You won't have a negative number. We don't know what the number is, but we know it'll be greater than 0. So set the shorter side to 0. 5 minus x is greater than 0, so 5 is greater than x. We now have two expressions that we can state in a compound equation. So state the intersection of the inequalities as a combined conjunction. So x will be greater than 3 seconds, and it'll be less than 5. The homework for lesson 5.5. For numbers 1 through 7, draw or construct a picture. Solve by adding the two shortest sides. If the two shortest sides are greater than the longest side, name the triangle. So an example, it might be scalene, equilateral, isosceles. If the two shorter sides are equal to the longer side, your picture should look like example 1C on page 234. If the segments look like example 1B on page 234, the answer is segments don't meet. So you'll have either a triangle, you'll have a line, or you'll have segments don't meet. Numbers 13 through 16, compare the unlabeled sides or angles. So an example, in number 13, the answer would be WJ is greater than BE. When I say unlabeled sides or angles, that means in the drawings, it's a side or angle that has no length or measure. Number 18 through 20, the answer will be greater than, less than, or equal to. And for number 26, do it just like I showed you in example 5. Have a blessed day, and if you need any help, contact me.